So here's the implementation in Java of the Newton-Raphson method. Um, yeah, we have a public class Newton-Raphson and then a public static void main. So if you have seen any object-oriented programming like in C++, you know that there are classes and then there are objects which are instances of these classes into which all the programming is organized into. And if you remember from C, there's always a main function from where everything begins. And so I'll not get into details of the class and other things, but let's just say this is required. So we leave it at that. And then this is the actual function which does the job of computing and finding out the root. We have a variable type double for floating points, and then we have x as with some initial guess. Tolerance is 0.001, iteration is 0, and we'll keep counting the iteration, and it's going to be integers only, so it's set as int. While something, some condition is true, we execute this. We have set this to true by default, so this is an infinite loop. We only break it when the convergence occurs. If no iterations were required, then we'll just appreciate that the guess was very good and print that out through these lines, with root being the answer we are looking for, and the tolerance is just what we have set. Inside the infinite loop, we calculate the function's value. This is the function from the video in QBasic. Then the derivative of that function with respect to x. Then here's a slight difference between what we did with the QBasic code, in which the convergence was based on the difference between subsequent guesses. Whereas here we are going by what we discussed in the class. Exactly the value of the function should be 0 when it's a root. And so we check if that value is less than certain tolerance. And if it is so, we break. Otherwise, we do an iteration, meaning we calculate the next guess based on the Newton-Raphson formula, and then output that value for each iteration. At the end of that, we set the new guess to be the current guess, and then we go back up here to calculate the value of the function, and so on and so forth. So I'm just showing this for the second function which we did with QBasic, and we had 3 roots in that. I'm just going to execute this and see what is the solution. So we get a solution of minus 13.06. Then I can go to minus 5. There was a solution near that. And we'll have one solution near, I think it was plus 5. There. So we had a 3.06, which is closer to plus 5. So those are the 3 solutions. Just to show you something, I guess we can call that as one of the difficulties with Newton-Raphson. Let's go back to x squared minus 3x plus 2. The derivative is 2x minus 3. And let's set the initial guess to 1.5. Note that at 1.5, the derivative value, the dfx, goes to 0. And so this means there can actually be no intercept to the x-axis. So if dfx is 0, you will end up getting the new guess to be infinity. And that's what will happen if you give a guess, which is going to give the function value at a maxima, local maxima or local minima. So this is something, is one of the limitations of Newton-Raphson method. So we have to change this value, even if so slightly, such that it doesn't become a local maximum or minima, and then we get the iteration to work and the solution to be arrived at. So if I go slightly on the other side, we'll see whether we get 2 or not. We do. So yeah, that's it. I hope that clarifies some things. You can use any language you like. If the algorithm implemented is this, then JavaScript, Python, MATLAB all should show you converging solutions.